Mobile robotics. Well, what is a mobile robot? Well, this is certainly one. It's not a KUKA product. As far as I know, KUKA has not been involved in the development of this, but it has some similarities. It has a manipulator, it has a navigation system, it has autonomous driving. So what we're talking about today has some similarities with this robot. And in the KUKA world, when we talk about mobile robotics, we actually divide them into two product groups. The first one is KMP, KUKA Mobile Platforms, and the second one is KMR, which are KUKA Mobile Robots. I got a question from Tero. The language here is in English, obviously. I hope that's okay with you, Tero. We will do Swedish in the afternoon. If we continue to look at the KUKA mobile platform, we have two different standard products in this range. It's the KMP 200 and the KMP 1500. And as the product name indicates, the 200 is for weights up to 200 kilos, and the 1500s are for loads up to 1500 kilos. Then, in addition to this, there are actually quite large Omni drives, which they are called, which are built on project base application only. And here we can find products all the way from 3 tons load up to several hundred tons, actually. But these are built on project base and case by case. But even though they share the same basic features as the standard products, as we will soon see. On the KMR side, on the other hand, we have the KMR EVA with the EVA robots mounted on the loads, which are, and we have also here done some project-based applications with the Quantec and the KMR KR60 on mobile platforms. Regardless of this, the KMR and the KMP have several common features. The first is the vehicle safety functions. That means that the mobile platform has laser scanners, which covers the surrounding area around the vehicle. And it actually divides the safety area in two zones. We have the yellow warning zone, and if someone enters that zone, the speed is reduced to safety speed. And then we have the safety field, which if anyone enters that field, causes a complete safe stop of the unit. Also on board are emergency stop buttons, obviously. And there are also audio signals and LED signals, which signals what status the vehicle is in and what it's about to do. There are, of course, batteries on board, lithium-ion batteries, and they can be charged directly or with a floor contact. There are two basic sets for the standard products available right now, 4 or 8 hours running time, and obviously the charging time will follow that. And these batteries are dimensioned that it can do a complete full charging cycle 5,000 times without deterioration. There is also a controller on board, of course, and this controller controls the KMP, and in the cases of KMR, it controls both the mobile platform and the robot itself. That means that there's only one controller for both the platform and the robot and the navigation. And you can configure it all from one software, one computer, if you so like. The navigation system is what's called a SLAM navigation. I will get back to you a little bit more about this, what this means, but it's a laser scanner based navigation. It's actually the same laser scanners that are used for the safety fields. It has it also involves a fleet management, and it's a very flexible, very easy handling system. We'll see that shortly. Of course, it's also possible to manually drive the KMPs, much like a radio-controlled car. And with that is a wireless controller. This is also used for the mapping of the area you need to place your KMP in. And for the KMRs, there is the standard product with the EVA on board, which is also suitable for clean room application, for example. And on the KMPs, there are lifting devices on board as well, if we need to manipulate the load in some way. All of these KMPs, the vehicles themselves, are equipped with something called Omniwheels, which gives a very high flexibility and high precision movements and some other features. So if you bear with me here, I'm gonna make life easy for myself and show you a video which explains the features of the Omniwheel quite good. Be careful, I think the volume is quite high here, so be warned.
Orange Intelligenz.
Okay, I think that video describes the flexibility better in word than I can do in words of the Omniwheel drive. I hope everyone saw the video okay. I think some of you had some problems, if I understand it correctly. It gives us a very high flexibility compared to a conventional maneuvering of a vehicle. For example, if you want to have a vehicle in this example which moves from corner to corner in a tight area, if you just have a conventional steering, you would do a movement something similar to this. While with the OmniDrive, you can just go diagonally like this. And also the turning radius will be much, much lower. If we have a tricycle driving, it will take here, but with the Omniwheel, we can really turn on a dime, as it's called, on a very tight spots. And it also, of course, gives us the flexibility that we don't really have to consider a turning radius of the vehicle when we plan the layout of our production. So we can actually do a lot of space saving when using this technology. So this gives us a really, really high flexibility when using these type of drives. Now, when it comes to navigation, well, of course, manual operation is possible, but typically there are several solutions for guiding autonomous vehicle. It could be inductive guidance or optical guidance with rotating lasers and mirrors. Magnetic grids is common. Rotating lasers, I mentioned, with reflectors, and indoor GPSs. All these technologies require that we have to do something in our production environment, set up reflectors, or have an indoor GPS coverage, or place a magnetic grid. So in our case, we have used what we call a SLAM navigation, which is also described best with a small video.
Orange Intelligenz.
You see my screen now, I think. My mistake. Still can't hear me? Yeah, you can hear me. So in the first step, we manually make the map by driving around the cars or the vehicle in the environment. We then tell the vehicle where in this map it is. By placing it into the map, basically by a click on the map. We define how to get from various locations, or if you like, we create the paths from going from A to B, for example. And we also provide these paths with different parameters, so that's speed limitations, etc., or road signs, if you like, what to look out for. So this is basically how we set up the navigation of this, which is actually quite fun to do. Now, this seems obviously very simple, but by doing this, we are not really completely finished, because now the vehicles can navigate and they know the roads, but they also need a command, often from a higher system, to give them missions to carry out. And this is done with a fleet management system in the vehicle, which we can have either a central fleet manager or directly in the vehicle if we like, which then communicates with a PLC or a higher level system, a ERP system or MES system. And this then orders our vehicles with the different tasks that are demanded from this. And there is a predefined interface for higher level system, which connects to our fleet manager system here. And this are some screenshots of how it in real time looks like. And this can also be cloud connected, so we can remotely monitor our fleet manager if we like. Now, that pretty much covers this. I've shown you quite a few YouTube videos, and I'll actually show you one more, which is a real-life application of truck assembly.
Unser Kunde hatte ein bestehendes, starres, fahrerloses Transport.
Our customer's previous transport system was driverless but rigid. His future production should be open and flexible, without any physical navigation elements such as track guidance. The challenge was to expand the existing system while reducing the number of AGV systems in a limited space.
Mein Name ist Robert Vogel.
My name is Robert Vogel. I am Key Account Manager for the automotive industry at KUKA. The automated guide transport vehicle transports the truck cab between the production plants. Thereby, the AGV drives through the plant. Every production step can be monitored and changed via the graphical user interface, developed especially for the customer.
KUKA liefert sämtliche Technologien.
KUKA provides all technologies of the value as a one-stop solution, starting with the automated guided vehicle KMP 1500, the KUKA mobile platform with a payload class of 1500 kilograms, and the SLAM-based navigation, its own fleet management, up to the integration services from KUKA.
Mein Name ist Alexander Zimmermann.
My name is Alexander Zimmerman. I am Portfolio Manager for the automotive industry, and I am responsible for our customers' requirements regarding automated guided transport systems and mobile robots. The main advantage of our transport system is scalability. Our transport system is able to define fixed procedures as well as dynamic and flexible processes. This means that we can react to changing production quantities, routes, or environments at any time. The KMP 1500 navigates exclusively by its laser data and the moving odometry. In addition, it is able to orientate itself using CAD models. Columns, lifters, or even route trains can be used for guidance. The CAD-based object recognition helps the vehicle to find its way even in narrow areas. For example, in narrow driveways, but also when positioning relative to existing objects. This means that they do not always have to be positioned exactly. They can have a certain tolerance. The KMP 1500 is charged while the production process is running inside the station by use charging plates integrated into the floor. The automated guided transport system navigates through the narrowest of routes and uses existing parking bays to ensure a smooth and cycle time optimized process. The Mecanum wheel helps the KMP 1500 to position itself very precisely on the smallest radius, even out of a standing position. If high-precision positioning below 3 millimeters is required, an additional built-in camera option can be integrated.
Orange Intelligenz.
So I think this was quite a nice installation from our point of view. I've shown you quite a few videos. There are a ton of more videos on these applications. This is just a small picking from them. Sorry. This is a picture from our tech center in Augsburg, but in fact we have at our tech center here in Gothenburg both the KMP EVA, KMR EVA, and the KMP 1500, and the 200 as well here. So anyone who is curious are, of course, welcome here to try it out and have a look at yourself. We can also arrange events at your site, if possible, where you can invite your customers and have a demonstration of this. So please don't hesitate to get in contact with us. This was basically all from us today. I hope we've find this fruitful and interesting.